Okay, good morning, everyone. Can you hear me? Okay, welcome to the Ateneo de Manila Department of Economics and Ateneo Center for Economics Research and Development Seminar Series. Our seminar series is being held twice a month. We invite scholars from the field of economics to present their most recent research. Before we start, you have seen this on your screen as the video is playing. Let me just repeat the house rules for our seminar. We will let the speaker finish her presentation first before we entertain questions. Zoom participants, kindly stay muted and stop sharing your video during the duration of the presentation. During Q&A, please virtually raise your hand and wait to be acknowledged. You may unmute and show yourself when asking your questions. Participants on Facebook, please post your questions in the comments sections. We will prioritize asking the questions with the most number of likes. We apologize in case we ran out of time and not able to read them all due to limited time. So our topic for today, we are very lucky to have our speaker. The topic is titled Help the Vulnerable, a Public Goods Experiment with Heterogeneous Marginal Returns. Dr. Ana Abatayo finished her PhD in economics at the University of Hawaii at Manoa with a specialization in environmental and natural resource economics, primarily using experimental economics methodology. She studies individual cooperative behavior in public goods and common pool resources. She has published her papers in top journals such as Journal of Environmental Economics and Management, Ecological Economics, and Proceedings of the National Academy of Sciences in the United States, or PNAS. Dr. Abatayo is currently affiliated with both Seneca College and the University of Guelph. She was previously at the Bocconi University and the Center for Open Science. Dr. Abatayo is also a product of Ateneo, obtaining her BS in Management Engineering here at Ateneo de Manila University. Without further ado, let's give the screen to Dr. Ana Abatayo.
Thank you, Maha, for that introduction, and thank you for the economics or the Department of Economics at ADMU for inviting me to speak today. Let me share my screen first. Okay, there. All right, so good morning, everyone, and thank you for coming online. Today, I will be sharing an economic experiment looking at cooperative behavior relating to the current COVID-19 pandemic. This is a research project with Dongze Lee, who is currently at the University of Guelph. All right, so the primary motivation for this research project is really COVID-19 and the fact that its consequences are more severe among individuals in vulnerable groups, sometimes even leading to death. So these individuals are individuals over the age of 60 and those with pre-existing health conditions. Vulnerable individuals partly get infected through the socially irresponsible behavior of other people. So examples of socially irresponsible behavior would be partying, hoarding, refusing to quarantine after international travels. So these types of behavior are really private contributions to a public bad that is more detrimental to individuals in vulnerable groups. On the flip side, you have individuals who engage in socially responsible behavior, such as wearing masks and social distancing. And these individuals are contributing privately to a public good that is more beneficial to vulnerable individuals. So what we do in this research project is to consider such a situation and to use an economic laboratory experiment to investigate cooperative behavior. So the next two slides are basically just figures that I lifted online, and they're showing COVID-19 deaths by age group. And what I want to show you here is really the fact that the most number of deaths occur for individuals age 60 and above. So this is for Canada, and it's not happening. This is for the Philippines. And you can imagine different countries will have similar graphs as well. Okay, so before I delve into the research design, the research questions that I asked, the nitty-gritty of it all, and what the implications of the assumptions that I make are, let me first give you a primer on privately provided public goods and bads, and how, in general, the game is set up. So consider a simplified society of 4 individuals. So you have individuals A, B, C, D in blue society. And a public good X exists, and public goods are non-rival and non-excludable. This means that any consumption of the public good by this person A does not reduce the consumption that the person B, C, or D can do. It's also non-excludable, meaning that person A cannot exclude anyone in the society, B, C, or D, from consuming this particular public good. Let's assume that the benefit from X is beta X and beta is equal to 0.4. Suppose that each individual is given an endowment of $20, and their decision is how much of this $20 they are going to contribute to a public pool that will be used to provide this public good. So if they don't, any endowment that they don't contribute to the pool, they keep. So it's included as part of their profit. But any contributions that they make to the public pool is summed up, and this produces the public good X. So what if, let's consider 2 situations. What if everyone in the society contributes fully to the public pool? So you will have a contribution of 20 times 4 individuals, which is 80, and each individual benefits by 0.4 of the public pool. So the profit of each individual would be 32. Social welfare will be 32, the profit of each individual times 4 individuals in society. That would be 128. If nobody contributes to the public pool, they keep the entire endowment, but no public good is produced, so it's 0 here. And each individual will profit 20. Welfare in society would be 4 times 20, which is 80. So as you can see, when you're comparing numbers, both at the individual level and at the level of society, there is an incentive for all people in the society, and there's an incentive for society as well to have everyone fully contribute their endowment to provide for the public good. So what if everyone else is providing the public good? What is person A's best response to this situation? So if person A cooperates and also provides contributes their entire endowment to the public good, you'll have a profit of 32 for person A. However, if person A cheats everyone else in society and decides to not contribute anything, so he keeps his entire endowment, but everyone in society is contributing 20, and since a public good is non-excludable, he benefits from that provision, he gets a profit of 44. So if you compare numbers, there is an incentive for person A to cheat and not provide anything to the public pool. But if person A is thinking this, person B, C, and D will also be thinking that. And in the end, nobody will end up providing anything to the public pool, and the public good will not be provided. So here we consider a situation where the benefit of each individual from the public good is 0.4. But what happens when the benefit becomes this? One person gets 0.3, one person gets 0.5, and another person gets 1.2. How will this change the behavior of individuals as it relates to how much they're contributing to the public pool? But also, if you take a look at this individual, person D, for every token, for every dollar that this person invests to the public pool, the return to that investment is 1.2. So the loss from investing is actually less than the returns from investing. So person D does not have any incentive to free ride on other people's contributions to the public pool. This is because fully contributing to the public pool is incentive compatible for him or her. And then we consider a similar situation for a public bad. So what we do in this research project is to use a laboratory experiment to investigate cooperative behavior in both a privately provided public good and a privately provided public bad. So we compare changes in behavior if individuals are contributing to a good and when they're contributing to a bad. with heterogeneous marginal per capita returns. This is not, the heterogeneous marginal per capita returns is not something that's new in the literature. But what is novel and what we add to the literature is we consider a more extreme heterogeneity in which a person in society is vulnerable. This is person D in the example that I gave earlier, or so highly dependent to the contributions to the public pool, such that this person no longer has an incentive to free ride on other people's contributions. On top of this, we examine whether information about the heterogeneity, so if other people in the society knows that the betas are heterogeneous, will just change their behavior, that information. And a nudge, if you tell people to help the vulnerable person in society, will that make individuals more cooperative or less cooperative? So there are two strands of literature that we're currently contributing to. First is in the framing of public goods games or public goods experiment. Sonnemans in 1998 actually took a look at step-level public goods and public bads game and compared the behavior of individuals in these two games. The game that he considered was binary. So instead of deciding how much of a $20 endowment you're going to contribute to the pool, there were only two choices: to contribute or to not contribute. He had it for 5 players, and the returns that he considered were homogeneous. He found that those in the step-level public goods game were more cooperative than those in the step-level public bads game. Reg and Tal in 2004 gave participants associations to cooperative norms. Basically, in the instructions that they gave the participants, they wrote this: you can either free ride or cooperate, instead of the more neutral, you get to decide how much of your endowment you contribute to the public pool, or you give to the public pool, or you invest in the public pool rather. So they found that when there are no approval incentives, this means that the player and the player's contributions are not revealed, cooperation increases with associations. We also contribute to the literature on heterogeneous returns in the experimental literature. So Fisher in 1995 ran an experiment with 4 individuals similar to ours, but 2 individuals had a beta of 0.3 and 2 individuals had a beta of 0.7. Fellner in 2010 had betas which were low and high, but both betas were less than 1. And he also had, on top of this, a treatment that's similar to what we're doing, which is an information treatment about the heterogeneity of the betas, or a no info treatment. And they found that high returns contribute more when the type can be identified. Without any information about heterogeneity, there is no difference in contribution types. Fishbacker in 2014 looked at heterogeneous returns, and they solicit conditional and unconditional contributions to disentangle the effect of heterogeneity from the effect of others' contributions. So unconditional contributions would be similar to the example that I showed you earlier. How much of a $20 endowment are you going to give to the public pool? While conditional contributions are basically you're given a schedule. So if the 3 other people in your group gave 10, how much are you going to give? What if they gave 20 in total? How much are you going to give? And so you have this schedule and you list down what your contribution is going to be given other people's contribution. And they found that heterogeneity in returns decreases unconditional contributions and only slightly reduces conditional contributions. All right. So given this setup that I showed in the previous slides, our research questions are as follows. Do high public good contributions imply low public bad contributions? When a person in the economy has public good returns of 100% or more from their and others' contributions, will there be full contributions from this person? Does the existence of this person influence others' contributions? And how will information nudging others to help this person affect others' behavior? So this is the public goods game that we use in our experiment, and this is standard to the literature. The profit of each individual I is equal to its endowment minus how much it decides to contribute to the public pool, plus its returns from the sum of everyone's contribution to the public pool times its marginal per capita return, or beta. The assumption that we need to make here is that beta is between 1 over n and 1 for a social dilemma to exist. So the symmetric Nash equilibrium in this case is for person I to not, for every person I in the economy to not contribute anything, which will yield a profit of E for each individual I, and a social welfare of N times E, since there are N individuals in the economy. The social optimum is to give everything to the public pool. This will yield a profit for each individual of N beta E. And since we assumed here, that beta, N beta is greater than 1, the profit at social optimum for each individual is greater than the profit at Nash equilibrium for each individual. The welfare for society is also greater than under social optimal than under Nash equilibrium. And then if everyone else in society is doing social optimum, so giving the entire endowment, there's an incentive for individual I to not give anything, to cheat the other people in society. This will give individual I the profit equal to endowment, what he keeps, plus n minus 1 beta E, which is the contribution of everyone else in society. And this is greater than the profits he gets from behaving cooperatively or doing what is socially optimal. And we get this inequality here because n beta is greater than 1 and beta is less than 1. So that's why we make this assumption here. All right, so the public bads game that we create is similar to our public goods game. But instead of a positive return to the public pool, we have a negative return to investments in the public pool. So this is negative. But to incentivize individuals to contribute or to invest something in the public pool, we put this additional term, which is basically the private returns for that individual. So delta here is assumed to be greater than 1 because the cost of investing in the public pool is equal to 1. So the coefficient here is 1. So this makes it this gives individual I an incentive to actually contribute to the public pool. The assumptions for beta are the same, and we make this additional assumption where delta minus beta n is less than 1. So the symmetric Nash equilibrium is reversed. Under a public bads, the Nash is for everyone to contribute everything to the public pool, which creates a public bad. And the profit would be delta E minus beta NE, which can be simplified to this. And the welfare for society would just be this times n individuals. The social optimum would be for everyone in society to not contribute anything to the public pool, which yields a profit of just the endowment for each individual. And that's greater than the profit under a Nash equilibrium where everyone cooperates because of this restriction that we made. And the profit for society, again, is n times endowment. Again, it's a social dilemma. When everyone is not contributing anything to the public pool, there is an incentive for individual I to contribute everything. This will yield a profit of delta E minus beta E to that individual, because delta, which is greater than 1, is greater than beta, which is less than 1. All right. So these are the two games that we have individuals play in our lab. A public goods game and a public bads game. And the parameters that we've chosen are standard in the public goods literature. So E is equal to 20, N is equal to 4. Delta was assumed to be greater than 1, and our choice of 2 is really ad hoc. It's the next whole number after 1. And the conditions that we have for the rest of our parameters are as follows. When we put in, these are what happens when we substitute in our numerical, our parameters here. And when we simplify that, we get the restriction that for both the public goods and the public bads game to be a social dilemma, beta should be less than 1, but greater than 0.25. So, given this restriction for a social dilemma for both our public goods and public bads game, we vary our marginal per capita returns as follows. So in the homogeneous case, which is our baseline, beta is equal to 0.4 for all 4 individuals. And in the heterogeneous which is considered our treatment, beta is equal to 0.3, 0.4, 0.5, and 1.2, as in the example that I gave earlier. So this table is basically just a summary of Nash equilibrium and social optimum, individual contributions, and group profits. So the only thing really is that when beta is greater than 1, the Nash equilibrium is in line with the social optimum decision, both for the public goods and the public bads game. So this is a summary of our treatments. We have the public goods game and the public bads game. If there is information about beta, betas are homogeneous, equal to 0.4. Without nudge, we call that baseline public goods and baseline public bads. If there is information about beta, betas are heterogeneous. Without nudge, we call that the diverse info public goods and the diverse info public bads. So the information is given as follows. So in the instructions that we give our participants, we show this. So person A's beta is equal to 0.3, C is 0.5, B is 0.4, and D is 1.2. And at the bottom, we say you are person A, so your beta is equal to 0.3. If there is no information about beta, we have heterogeneous beta without knowledge. We call that the diverse no info PG and the diverse no info PB. And in the instructions given to the participants, we just tell them the computer screen will display the period number and the value of beta assigned to you. So on the computer screen, when they start the game, they will see your beta is equal to 0.3. But they don't know the distribution of betas in the economy. They don't know that other people have different betas from them as well. And lastly, if there is information about beta, it's heterogeneous with nudge. For public goods and public bads, we show them a similar distribution as the diverse treatment, but we add this line for the nudge treatment. The total group payoff is highest when everyone contributes all their tokens to the pool. Person D will especially benefit from your contribution. Help person D contribute to the pool. This is for the public goods game. If it's a public bads game, it's the opposite. It's highest when no one contributes any of their tokens. When everyone contributes none of their tokens to the pool, person D will especially benefit from 0 contributions. Help person D do not contribute to the pool. All right, so we have participants play this game for 20 rounds. And we divide our 20 rounds into 2 parts, part 1 and part 2. In part 1, we run a public goods game. If we run a public goods game in part 1, we run a public bads game for part 2. We also switch the order so we can control for order effects. We run a public bads game for part 1 and a public goods game for part 2. So this treatment is within subjects, meaning that we are testing the behavior of the exact same individuals in the exact same group, moving between public goods game and public bads game. Our treatments, baseline, diverse info, diverse no info, and nudge, it's between subjects. So we have different individuals participating in each of these 4 treatments. The individuals are randomly distributed into these 4 treatments, so that the type of individual does not really affect how they behave in each particular treatment. So our experiments were conducted in July 2020. Experiments were run online via O3. Students were recruited from the FARI lab at the University of Guelph recruitment website. They were paid via PayPal. So we asked individuals to actually open a PayPal account if they didn't have one. But if they refuse to, they can always pick up their earnings from the FARI lab. Session procedures were as follows. So this is unusual because it's not the regular laboratory experiment where we bring individuals into the lab and we see what's happening because they're all physically there. This is online, so in online experiments, people just suddenly disappear and you can't contact them, or the internet connection is bad and they log off. So it's hard to really fully control a lot of things. So this is what we did. We have them signed to WebEx. And then in WebEx, we made sure that we had participants in multiples of 4. If we had that, we then gave them personal O3 links. Once they click on that link, they ask for their consent to participate for the experiment, they're given the instructions, and then they play the game with the other members in that session. So in the WebEx, the WebEx is turned on for the duration of the entire experiment, so we know how to contact the participant. But participants were asked to mute themselves and to turn off their videos. They were also not able to chat with the other participants. So after the game, they were paid. The game lasted for 90 minutes with approximately $25 per participant. So we ran 33 sessions in total with 472 students in 118 independent groups. So we had instances where 1 or 2 participants in a group do not make a decision for 20 minutes or more. If that happens, the computer or the experimenter would automatically make a decision for that person, and the decision made would be 0. For the analysis that we do when we discuss our results, we actually drop the entire group from our analysis. We also run the analysis by just dropping the person, and that does not change our results. All right. So first we compare welfare between the public goods game and the public bads game. So it's not good to compare just how much the average actual welfare was between the public goods game and the public bads game for our different treatments, because the optimal welfare to begin with is different. It's 192 for the public goods game and 80 for the public bads game. So what we do is we normalized the welfare based on the distance of the actual welfare from the optimal welfare. So that's what you see in the horizontal and the vertical axis. So the closer a bar is to 0, that means the closer the decisions, the more cooperative the individuals were. So the closer the society or the economy's welfare was to the socially optimal. So the black bars would be public goods and the gray bars would be public bads. And in all treatments, you see that the public goods individuals here are always more cooperative than individuals in the public bads. So there is more cooperation when individuals are playing a public goods game compared to when they're playing a public bads game. Treatment effects. So your horizontal axis are periods. This is for the public goods game and the public bads game. And on your vertical axis is average group contribution. Since we're considering group contributions, it's over 80 because each individual has an endowment of 20 times 4 individuals. So maximum contribution to the public pool is 80. All right, so the Nash equilibrium for the public goods is 0, and the optimal is a full contribution of 80, and it's the reverse for the public bad. Social optimum is a contribution of 0, and Nash would be a contribution of 80. So as you can see here, the nudge treatment seems to always be more cooperative and closer to the social optimum level of cooperation for both the public goods game and the public bads game. The diverse info treatment do not appear to be significantly different from our baseline treatment and in the public goods game. In the public bads game, they are lower, so that means they're closer to the socially optimum level, but they're not as close as compared to the nudge treatment. So we test that. We ran Wilcoxon Manor-Whitney test comparing our treatments with the baseline treatment. So the symbols that you see here are basically comparing the adjacent treatment. So this one would be for diverse info. And the number of symbols refer to the statistical level. So this is statistically insignificant. This is statistically significant at the 1% level, and nudge treatment, individuals here are more cooperative than in the baseline treatment. So that's for the public good. For the public bad, all our treatments are more cooperative than our baseline homogeneous treatment. However, when you compare the treatments with one another, you'll find that diverse info is not statistically significantly different from diverse no info. So giving individuals information about how heterogeneous their economy is in terms of benefits from the public good or benefits from the public bad do not actually change cooperative behavior, but nudging makes a difference on how people cooperate. So nudge here is closer to the social optimum of zero contributions. Regression results support the non-parametric test that we showed earlier. So nudge increases public good contributions and decreases public bad contributions. In the public bads game, diverse inf and diverse no inf also decrease individual contributions to the public bad, but not as much as nudge. So we run wald tests, F tests, and we find that there's the difference between nudge and our diverse treatments with info and without info are statistically significant. Okay, now we look at the effect of heterogeneity for the public goods game. So we have here diverse info, diverse no info, and nudge. Our vertical axis has changed. It's average individual contribution now. So this is baseline, and you can see the one thing that you see when you look at these three panels is that individuals with marginal per capita returns of 1.2 are actually contributing more than any other individual in society. However, their MPCRs are 1.2. So that means they should be fully contributing to the public good because they don't have an incentive to not fully contribute. So we should have the expectation or the prediction was for MPCRs of 1.2 individuals to be contributing here, but they're actually not there. So that's one thing to note. The second thing is that when you compare these individuals with a baseline where MPCR is 0.4, you see that those with MPCRs of 0.5, the diamonds, and those with MPCRs of 0.3, the circles, they seem to be lower. So their contributions seem to be lower than baseline. So that means that heterogeneity might be affecting them somewhat, but the effect is not so big. It's not like if you look at the difference between baseline and these MPCRs, it's not as big as the difference between baseline and MPCR of equal to 1.2. So that's for the diverse treatment. Diverse info. Diverse no info, you still see the effect of having a high MPCR that's greater than 1, but it's a bit messy here, and it does not look like any other MPCRs or individuals with MPCRs less than 1 actually behave statistically significantly different from individuals with MPCRs of 0.4. In this panel, there seemed to be a difference. These groups of individuals with marginal per capita returns of 0.5 seem to be contributing more in the nudge treatment than individuals in baseline without the nudge treatment. For the public bads game, again, it's the opposite. So the closer you are to 0, the more social optimally you're behaving, or the more cooperative you are. And again, you see those with MPCRs of 1.2 behaving more cooperatively than anyone else in society. But again, I mean, they're not behaving as cooperative as the theory predicted them to behave. For diverse info, there seems to be no difference between baseline and all other players in the heterogeneous society. For diverse info, for diverse no info, but for nudge, everyone else seemed to have been affected by the nudge treatment. So those with MPCR of MPCRs of 0.3, 0.4, and 0.5, they're behaving more cooperatively than in this treatment, in this baseline where MPCRs were homogeneous, but where also nudge did not exist. So it seems like for the public bads game, nudging individuals actually changes their behavior and makes them more cooperative. So we look at non-parametric tests, and we find support for the visual results that we show, that we seen in the previous slide. Those with MPCRs of 1.2 are more cooperative in the public goods game. Their contributions are higher. They're also more cooperative in the public bads game. Their contributions are lower. Those with MPCR of 0.5 in the nudge treatment also become more cooperative, while everyone in the public goods game in the nudge treatment become more cooperative. Our regression results support the main results that we saw in our non-parametric tests. So more cooperation for MPCRs equal to 1.2 and more cooperation for an MPCR equal to 0.5 in the nudge treatment. Interestingly, we get these additional results that we didn't see when we did our non-parametric test, which is more cooperation in the nudge treatment for MPCR of 3 and 0.4 as well. And less cooperation in the diverse info treatment for MPCRs less than 1, and in the diverse no info treatment for an MPCR equal to 0.3. So this is in line actually with the previous literature where they say that the lower your marginal per capita return, the less contribution there will be to the public good. For the public bad, again, we're able to confirm our non-parametric result. And we have this interesting result for 0.5, which we didn't see in our non-parametric test. Those with marginal per capita returns of 0.5 actually contribute or become more cooperative in our diverse no info treatment. All right, so to conclude, we were able to see that when we're comparing the behavior in our public goods game with the behavior in our public bads game, we find that individuals are more cooperative in providing for a public good than in stopping themselves from providing a public bad. This means that framing is important, and we've seen that in the previous literature. Framing affects how people behave. So, for example, because I work on environmental issues, asking individuals to contribute for climate mitigation might be a better strategy to make them more cooperative and to actually contribute for climate mitigation than asking individuals to reduce their greenhouse gas emissions. Action also, perhaps the more cooperative behavior that we see in the public goods game is because action produces a tangible result. So you can actually imagine a status quo. When you're when you're contributing to a public good, you're moving up from the status quo. But in a public bads game, you have the status quo, and when you don't contribute to the public bad, it's actually keeping the status quo. So perhaps we see more cooperative behavior in the public goods game because there is a tangible outcome from it compared to the public bads game where you're just keeping the status quo. Contributing to something good also produces warm glow. It makes you feel better about yourself. And this might be the reason why we have more cooperative individuals in the public goods game than in the public bads game. And the thing to note is that these are the exact same individuals. We have the exact same individual in this exact same group play both the public goods and the public bads game. Next, we find that vulnerable individuals are not fully cooperative, which is kind of weird. Like when you know you're going to die if you get infected by COVID-19, why are you engaging in socially irresponsible behavior? It doesn't make sense, but that's our result. So it begs the question, is there something that our current profit function, because it's a simplified version of what people take into consideration when they're making these kinds of decisions. So is there something that the profit function does not account for? For example, like, is this learning? So if we had individuals play the game for, I don't know, 40 rounds instead of 20 rounds, will the behavior of these vulnerable groups of individuals actually be closer to what is socially optimal or what is equilibrium in their case, because it's the same? Or is it reciprocity? Are these individuals, instead of fully cooperating, which they know, they should know that it's the best that they can do, given the institutions that they are given, are they not fully cooperating because it's their way of punishing the other individuals in the group from not fully cooperating? So remember that we run it for 20 rounds with the exact same group of individuals. So if they see individuals in their economy, in their group, not fully cooperating, they might want to punish those individuals, but also not fully cooperating, because they know that any contribution they make to the public pool actually benefits other people in the group as well. And lastly, we saw that nudge increases cooperation. This is a good thing. This means that people respond to pleas for help, which is always good for society, especially in this current time. But also the kind of nudge that we created, we asked them specifically to help an individual. So help person D, that's what we told them. We didn't tell them, make your society better off or help society. So we targeted a specific individual that needed help. And I think that's one of the reasons why it was successful in making individuals more cooperative. So this is similar to what UNICEF is doing with its Sponsor the Child program, for example. So instead of like help children in developing countries, the donors actually get the chance to get to know the individual children that they are helping. And they're provided feedback regarding where the money that they donated went. And I think that is, people feel there's like a personal connection with who you're helping. You know exactly where your money is going. And I think that's important when you're trying to make individuals contribute more to the public pool, make them more cooperative or make them more helpful. And that's it. Thank you so much for your time and for your attention.
Thank you very much, Anna. Very interesting research, actually. Okay, so now we open the floor or the screen for questions. Anybody from Facebook or from the Zoom participants? You can unmute yourself and show yourself as well. Or any questions?
I have a question, Maha. Just from reading the news, for example, in the US, in terms of engagement in public bed, it seems that there is a political divide. Republicans, for example, are reported to be to engage more in public beds, not wearing masks, less social distancing than for example, Democrats. Is something like that? Can that be controlled for in these sorts of experiments? And has there been attempts to do that?
That's actually a very interesting point. And we did think of considering that when we were planning our experiment. So the experiment was ran in Canada. And so the divide between conservative and liberal is not that huge in terms of the pandemic. But we did think of running the experiment in the US as well and getting participants from both sides of the political spectrum to see if we can relate their political affiliation with their behavior in the public goods and the public bads game. But we haven't gotten to that yet. We did apply for a bigger grant that runs it like in different countries to see like differences in country behavior. That's a next step, but we haven't gotten to it. Yeah, but that's interesting. We're very much interested in that as well.
Okay, thank you.
Okay, thank you, Jeff. Any other question from the Zoom participants? Alvin? Okay, Alvin and then Randy.
Hi, good morning, Anna. Thank you for a very nice presentation. Just as a follow-up to what Jeff has shared or has asked, I was thinking of the context specificity of these media applications in different countries because the behavior might be formed by certain cultural ideas. So maybe in your future, as you had said, maybe you're going to do some kind of country context or distribute the research or expand the research further. In this round, may I know what are the nationalities of the participants?
We don't actually have. We did. Had them do a questionnaire afterwards. We didn't
Mm,
actually solicit nationalities, but we solicited race. Uh,
mm,
if they're Southeast Asian or if
mm,
they're North South American, they're mostly. So they're mostly Canadians and mostly North Americans. We have a couple of individuals from the Caribbean and a couple of Southeast Asians. We did include that when we ran regressions, and we asked a couple of COVID questions as well. And the only term that we found statistical to affect the behavior in the cooperative behavior statistically significantly is whether they're living in a house with someone older than 60 years old. So if they have someone older than 60 years old in their household, they're more likely to cooperate in both the public goods and the public bads game. But that's it. Like everything else is statistically insignificant. Even gender was statistically insignificant.
thank you.
Thanks, Alvin. Randy, you were unmuting yourself earlier.
Yes. Congratulations, and it's a very interesting paper experiment and very interesting result. No? So I don't know if in your experiment you can be able to distinguish the value attached to the individual over the outcome, or I mean, are the individuals acting like that because they attach a certain value, I mean, to that outcome, or is it because individuals see that they're able to do something to achieve that certain outcomes? Well, that's also I just thought of that question because in among our students, when we ask them to do something, for example, to do some volunteering work, um, you're right, no? I mean, your experiment validates the view that I mean, if you give students specific tasks, I mean, I think your Save the Children or yung UNICEF campaign is a very good example. They will be able to do it, but if you give them something, parang some bold vision, it's difficult for them to aspire for. So I don't know if you can if those two can be distinguished in your experiments. Experiment. Thank you.
That's actually a good point, especially given the result of the nudge treatment. And that just reminded me. So I'm teaching a class right now, and I ask students to do a policy memo and to identify a problem and their recommendations for how to solve that problem, like recommend it to the government or whoever. And they have these very vague recommendations. And I tell them, it's like, imagine yourself as the boss and you have minions and you're telling your minions, this is what you need to do to solve this problem. So your recommendations have to be as specific as possible and you can't be vague. So I guess that's what happened with the nudge treatment. Since it was very specific, you need to help person D, that actually enabled that told them exactly what they need to do. But if you tell them help society, they might not know, like there are many different ways of helping society. So I don't know if like what I'm doing exactly is helping society or not. So that's actually a good point. However, like we need to run another treatment to be able to like scientifically test that, a treatment that just says help the society, and we can compare whether that treatment makes a difference in the behavior of individuals. But yeah, that's interesting.
Yeah, thanks. Hope that if you do the extension, you can also
Yeah.
some
Yes.
results as well. Thank you.
Thank you, Randy. Any other questions from Zoom participants?
Hmm.
Yes, Lina.
Yeah. In relation to Randy's question, by the way, thank you very much for the very clear presentation and a very interesting paper, Anna. In relation to Randy's question, did you ask questions on attitudes, say charitable tendencies of the participants in your survey instrument, in your questionnaire? Because that could be used in the regression analysis and see if that has an impact.
That's actually, I don't think we ask specifically like how much have you donated money to like certain organizations, but I think so we didn't ask that question, which would have been good. These regrets come after you run the experiment. But I think we ask them so we ask COVID related questions, and I think we ask like like have you engaged in social distancing, or like how much do you agree with, so that we can use that as a proxy to measure how charitable they are as a person. But that's actually, and that's good. But yeah, too bad we didn't actually solicit like if they've donated anything to any charity in the last few months. That would have been that might help explain their behavior.
And then I have another question regarding the explanation of the public good and the public bad. How are these explained to the participants? Did you give specific what the public good is, of what the public bad is in relation, say, to COVID?
Oh, no. So the experiment is unframed. So they're not given context. They're just told that, so they're just given the rules. So there is we called it a pool that you can invest in, and any investment to the pool will yield returns of beta times the sum of everyone else's investment. So that's how we explained it. So we explained it in a language that's neutral, so they don't start thinking of practical examples of what this could be.
But sometimes the reaction to certain, to charity work, or contributing to it or not contributing to something that is bad, will depend on the context, right? So there's this issue in that kind of generic situation.
For sure, yes. And that was when we're thinking whether to do it framed or unframed, that was something that we wanted to control for, because like your attachment to particular issues, that's very hard to gauge. Like we can run a questionnaire afterwards to see, but that is like self-reported, and you can lie in the way you report your preferences. And we just wanted to do away with that kind of variability. So we decided to do it unframed, so we don't have to deal with like whether they have a preference for climate change, or they don't believe that climate change is real, or they like to help COVID affected individuals, or they don't believe that there is really COVID. So so that we don't end up controlling for those variables, we decided to just run it without relating to them.
Yeah, but that will limit your conclusions regarding the implication of the result.
Yeah, for sure. It also limits like the external validity of it all, because they're in a bubble. They're not in the real situation.
Yeah. My second question is that you did not use split samples for public good and public bads. Yeah. I would like to know the profile of your participants. Would they be able to really absorb or realize and appreciate the difference between a public good and a public bad, or simply it is just a difference on the social returns? Were they able to observe that difference?
No, so they don't know that one is a public good and they don't know that one is a public bad. They just know that, the way we earn money has changed, but also to make sure that they actually understand that it has changed, because sometimes like they're just clicking. It's 20 rounds, so they can get bored. We actually had them do a quiz to measure their understanding of what has changed. And we used that to check if they understood, and they did. Most of them got it right.
Yeah, I'm a little bit concerned about this, because you made statements about the implications of the results regarding if it's a public bad, then you are trying to maintain the status quo. It may not be that case, right? And then there is that implication statement in your paper, and that would be a little bit too presumptuous to make a statement as a result of your experiment.
I guess
Correct?
like even when you don't know whether, oh sorry, I guess even when you don't know that you're contributing to a public bad or not contributing to a public good, in the public bads game, you are contributing something. So you're losing your endowment and you're building something. Like even if you just look at the math of it all, in the public bads, you're actually contributing zero. So you're not contributing anything. And you know, since like nothing is happening, you're not building something. So you're basically keeping it as it is. Like the highest possible profit you can get from a public goods game is higher than your endowment of 20, but the highest possible profit you can get from a public bads game is just 20, which is the status quo. Like nothing happened. There's no game. You go to the lab, you don't do anything, and you get 20.
So again, it's the status quo in relation to that particular game setup,
yes,
right?
Yes. Mm-hmm.
Okay, thank you.
Thank you, Lina. Any other question from Zoom participants? Okay, Anna, I have a question.
Okay.
Periods, since we still have time, since the periods, am I right in my understanding, the periods that you have, does that represent time over, or it's just a repeated game?
Yeah, it's a repeated game. So repeated for 20 times.
Also, it's just really a measure whether you're trying to gauge whether over time the participants would be able to understand the game.
That's true, yes. So if you compare
Okay.
their behavior in round 1 with round 10, then that means like that shows how much they've learned by playing the game over and over 10 times.
So it's really kind of a one shot in a way, is that right?
That's true. Yes. So it's a one-shot game repeated 10 times.
Because I was just trying to think when you get the counterintuitive results of the vulnerable not wanting to contribute, I was thinking that maybe it has something to do with how they are discounting the future, but you can't have that in your setup because it's a one shot. Is that right?
So
right?
Let's see. Discounting the future would be their future. So their behavior in round 20 does not mean much.
Yeah.
It's one shot, and then it's their earnings is summed up without the discount factor. So yeah.
So I guess the puzzle that you have may have something to do with that, the time frame, because they are vulnerable already. The returns to whatever contribution they would have, if it's, a longer period of time, might be teased out why you're having that counterintuitive results that you're saying that the vulnerable are less likely to contribute to the public goods.
Well, okay, they are contributing more than everyone else in the group, but they're not contributing fully, which is what was like weird, because if the profits you get from fully contributing is more than the loss you make from fully contributing, then it's just rational. There's not even a game for you. It's just rational to fully contribute anything. So it could be that they don't understand it, or it could be that they're just trying things out and they haven't gotten to the point where they've reached their steady state.
Okay. Yeah, and then another, I think this is a follow-up comment to what Randy and Lina has already mentioned with regards to the nudge, because in your experiment, the setup is only that you only have one type of information, right? Identifying. So it would be, I guess, in your future work, maybe another interesting, I guess, teasing out, trying to test the significance of the type of nudge that you would give. There's a strong,
yeah, definitely.
Or if you just announce that, okay, try, what we see now, trying to convince people to donate, and then, or the one that even World Vision does that, you have a kid where you can support their education. So I guess trying to have that difference would have a lot of policy implication for policy, policy inputs.
Definitely. That's very interesting, and it's also good to know, like, I mean, because a lot of people say nudge helps like most of the time. It's been seen like to be effective in a lot of different cases, but it's actually nice to be able to identify which cases it worked it works and when it doesn't work, so that you can, when you implement it in reality, you know exactly what you need to be implementing.
Yes. Okay, it's already 11. Unless anyone in the Zoom would have some burning question, we can entertain one. Meron ba?
Clarification lang.
Yes, who is that? Albi?
Joey.
Joey, yes, Joey.
Clarification lang. Thank you, Anna. What is the definition or the selection of who is vulnerable? Sorry if I did not catch it.
So the definition of who is vulnerable is if their marginal per capita return is greater than 1. So that means that whatever the contribution is of the society to the creation of the public to the public good, they're the ones that are most affected by it, regardless of whether it's a public good or a public bad. So they're vulnerable to the amount of public good or bad that's created.
Negatively affected or
Sorry. Yes, they are affected by it. They're the ones that are affected the most because they have the highest marginal per capita return.
okay. Thanks.
Thanks, Joey. Meron palang pahabol na question from Facebook, from Bing Radok. Hi, Anna. How were the MPCRs assigned within each group? Also curious about the distribution of MPCRs, e.g. point and difference to trigger heterogeneity.
So the MPCRs were assigned randomly. So at the start of the session, individuals were assigned into groups of 4 randomly, and then they were randomly assigned MPCRs. We picked 0.4 in the baseline because that's what's standard in the literature, and then we basically proceeded from that. So if you sum up our heterogeneous MPCRs, 0.3, 0.4, 0.5, the average of that is 0.4. And we picked 1.2 that's actually ad hoc. Anything greater than, we just wanted something that's greater than 1. So we picked 1.2.
Okay. I guess that's the last question. So thank you very much, Anna, for, I think it's already late time, right? For sharing your time with us and sharing your research with us. But before we end on Facebook and also on Zoom, let me just invite everyone to our next seminar. So this will be on February 10, also Wednesday and 10 a.m. Our speaker is Professor Toshi Arimura from Waseda University. He will be talking about, do regional emissions trading schemes lead to carbon leakage within firms? A case of Tokyo Saitama emission trading schemes in Japan. So this will be the first seminar in Feb, and we will have another one on the third week of February. Okay, so again, please join me in thanking Anna. We can give her a virtual applause, or